So we're about to learn about sum and differences of functions. So these are operations that we can do to two different functions or more, but we're going to stick to two functions right now. Now, before we get started, I want to go over some notation that it looks like, because the notation can look a little different. On the left-hand side, I'm going to talk about sum, um, the sum operation of functions. And then on the right-hand side, I'm going to be talking about the differences operation. Okay, so let's say we have a function f of x and we have a function g of x. And a sum, well, that's when we're adding two things together. So we are going to add these two functions together. Now there's just different ways to notate it. So how to notate. Okay, it's not super hard. The easiest one to think of is f of x plus g of x, and that equals some new function h of x. Okay, now how about, there's a different way to show this. The different way would actually be putting your f plus g in brackets and then placing x there. And that's also representing h of x. Now there's another way, or these are the two ways, sorry. If we look at differences of functions, let's say we again have our functions f of x and g of x. How to notate this is very similar, except it's difference, right? It's the difference of these two things, which is subtraction. If you're thinking subtraction, well, again, it's going to be f of x minus g of x, and that equals some new function h of x. And then we could have brackets here and represent it in such a manner that it looks like this. Now recognize when you add things together, it doesn't necessarily matter whether you add g to f or f to g, because it's the same thing. Whereas it does matter for f minus g, because f minus g is totally different and does not equal g minus f. Okay, so it's very similar to as if you do 4 minus 5, well, that would equal -1, whereas 5 minus 4, that equals +1, which are two totally different values. They don't equal. Okay, so since we have some time, let's do a few examples here. The first example, let's just say determine h of x. Okay, so this is example 1, and let's determine the function h of x. And let's say for a, h of x equals g of x plus f of x. Okay, and then b over here, h of x in this case would equal, let's say, g of x minus f of x. Okay, so let's give some values to f of x. So let's say f of x equals 3 minus x, and g of x equals 2 plus 3x. Okay, so here's our brand new example. Determine h of x if f of x equals 3 minus x and g of x equals 2 plus 3x. So let's focus on a here. Well, if we want to determine h of x, we need to take our function g of x and place it there. So g of x will be 2 plus 3x. And our function f of x, we're going to add, I'm going to put brackets around this and place it down here, 3 minus x. So substitute f of x for what the function actually is, its actual equation. Now from here we can simplify this, we can combine like terms. So notice we have x values and we have constants, so we can add those things together as long as they're like terms. So h of x would equal, that would give me 2 plus 5, or 2 plus 3, which is 5, and then 3x minus x, which gives me positive 2x. So there is my h of x function. Now let's go over to our difference here. So h of x I'm going to substitute g of x for the equation that it is. So 2 plus 3x, 2 plus 3x, and then subtract. I'm going to bracket this because now this is really important where the brackets come in, because that negative symbol here is going to affect a few things. So I'm going to substitute f of x for the actual equation 3 minus x. Now, there's a few different ways to do this, but what I'm going to do is I'm going to apply that negative inside the brackets. So I'm going to get 2 plus 3x, negative 1. So negative 1 times 3 gives me negative 3. Negative 1 times negative x gives me positive x. And then from there I can, again, combine like terms. So 2 minus 3, that gives me negative 1. And then 3x plus x gives me positive 4x. So there is my h of x function. Okay, going down a little further, we could expand on this. So determine, let's say it asks us to determine what g minus f at 2 is. Okay, so if we were given a question like this, we can do this a multitude of different ways. We could substitute 2 in, because remember, this notation we can actually write as g at 2 minus f at 2. So recognize that this also equals h at 2. Okay, so again, a few different ways to do this. Let's do it one way on the left-hand side and one other way on the right-hand side. So let's use h of x, the equation that we got here, and just plug in 2. So negative 1 plus 4 times 2. Okay, so that would give me negative 1 plus 8, which would give me positive 7 here. Okay, there's another way of doing this, and that other way is taking our original function g of x and plugging 2 in there. So 2 plus 3 times 2, and then subtracting f at 2. So f at 2 would be 3 minus 2. Okay, so I got this from here, up top on the screen, and then g at 2, I used the equation of g of x and plugged in 2 for x. Now from here, we can simplify this. So this is 6, okay, 3 times 2 is 6, and then 2 plus 6 would give me 8. And then this, 3 minus 2 would give me 1, so I'd get 8 minus 1, and 7, this would give me 7. So two different ways to answer the same type of question. So if you're actually asked for the function itself, you can simply plug it in to the functions that you're given, so like g of x and f of x, and then subtract or add those depending on the type of question. Or you can actually determine the brand new equation, h of x, and then plug that value in there, and you'll get the same answer.